Hello, sleepy scientist stories. Tonight, we drift far beyond Earth, past the Moon, past Mars, past everything your average telescope can see into the dark, cold void of deep space. But don't worry, you're safe here. You're with the sleepy scientist. Now, let me tell you a story. A few months ago, astronomers pointed their instruments at a faint, quiet little galaxy, barely more than a cosmic village. And what they found there was a monster. A behemoth black hole, hiding in plain sight. Something that shouldn't be there, couldn't be there. And yet it was. So, tonight, we unravel the mystery of how a colossal black hole, a gravitational titan, ended up lurking inside a galaxy the size of a cosmic parking lot. We'll talk about what black holes actually are, how big this one is, why this location is so shocking, what it tells us about the early universe, and what it might mean for the future of our understanding of everything. Let's get sleepy and get curious. To understand the weirdness of this discovery, we first need to understand black holes, not the sci-fi version, the real ones. Even though, frankly, reality might be stranger. A black hole forms when a massive star runs out of fuel. It collapses under its own gravity, and if it's massive enough, nothing can stop the collapse. The result? A region in space where gravity is so intense, not even light can escape. We call it a singularity, a place where physics breaks down, math screams, and time probably cries in a corner. Around this singularity is something called the event horizon, a boundary. If anything crosses it, light, matter, hope, it's gone forever. Black holes come in different sizes. Stellar black holes, around 3 to 10 times the mass of our sun. Supermassive black holes, millions or billions of suns packed into one point. And then there's the weird one, too small to anchor a galaxy. And for a long time, mostly theoretical, intermediate mass black holes, the awkward middle child, too big to form from just one star. Until recently, astronomers spotted this black hole in a place they least expected, inside a tiny dwarf galaxy. That's like finding a whale in a swimming pool. This galaxy is called insert real or fictionalized galaxy. For example, UGC 11411, one of many small, faint dwarf galaxies floating quietly on the outskirts of larger galactic clusters. No bright quasars, no dramatic supernova. Just a humble blob of gas, stars, and dust. But at its center, a black hole estimated to be over 1 million times the mass of the sun. Let that settle in. This isn't a typical stellar black hole. It's not even just big. It's behemoth-level big, in a galaxy 1,000 times too small to host one. How? Why? No one knows for sure. But we have theories. Most massive black holes live at the centers of huge galaxies, like our Milky Way or Andromeda. These galaxies have enough mass and activity to feed black holes over billions of years. But this dwarf galaxy, it doesn't have enough gas, stars, or time to grow a black hole this big unless something unexpected happened. Which brings us to a few cosmic possibilities. It's a primordial black hole formed shortly after the Big Bang, not from a star, but from quantum chaos. Rare, hypothetical, but not impossible. Galaxy merger history. Maybe this dwarf galaxy wasn't always so small. Maybe it was once bigger and got torn apart. The black hole, just the last remnant of a more violent past. We're missing a whole class of black holes. Maybe intermediate mass black holes are more common than we think. But we've just been looking in the wrong places. Good question, because black holes don't emit light, but they do interact with the matter around them. When gas, dust, or even stars get too close, they heat up as they spiral in emitting X-rays, infrared light, or creating subtle ripples in starlight that we can detect. In this case, scientists used X-ray observatories like Chandra infrared surveys from JWST and radio wave studies to measure how the center of this galaxy was behaving strangely. The motions of stars nearby, too fast, too chaotic. Something was pulling them, something invisible, massive, and very compact. Only one answer made sense: a black hole. This discovery challenges the traditional model of galactic evolution. If black holes this massive can exist in tiny galaxies, then either our galaxy models are wrong. The universe is hiding way more black holes than we thought, or the early universe made monsters fast and early. This also connects to dark matter research, gravitational wave detection, and even how life evolves. Since black holes can influence the radiation environment of galaxies, this discovery opens new mysteries. Are dwarf galaxies secretly littered with giant black holes? Could small black holes merge into larger ones without galaxy collisions? Are we looking at the cosmic fossils of a forgotten era? It also forces us to re-examine how fast black holes can grow, whether galaxies form around black holes or vice versa, and whether some black holes have existed longer than the stars themselves. So, the next time you look up at the night sky, remember, there may be monsters in the dark, not evil ones, not sentient ones, just ancient, enormous mysteries, silently warping space and time. This behemoth black hole, hidden in a quiet, unremarkable part of the cosmos, is a reminder. The universe is still full of surprises, and sometimes the smallest places hide the biggest secrets. Sleep well, explorers, and remember, curiosity is your flashlight in the dark. See you in the next chapter of the Sleepy Scientist Stories. Don't forget to like, subscribe, and gently whisper gravitational anomalies into the comments section below.